So differentiable, you want to think of it as more than just take the derivative. Okay, so it's differentiable if the derivative exists. Okay, so let's think about what that derivative exists means. Remember that the derivative is a limit, and so that means I've got to be able to find the limit that gives me the slope of the one tangent line at the point A. So there's one tangent line. So that, remember, the derivative is a limit, so the limit from the left-hand side has to equal the limit from the right-hand side. So here we go. Differentiable, it must be continuous. First has to be continuous. You cannot draw a tangent line when there's a hole in the graph or a vertical asymptote. Has to be continuous and doesn't have one of these four bad things: a cusp, a corner, an endpoint, or a vertical tangent. Okay, so let me give you some examples of what these are. So a cusp, so that's on that graph, y equal x to the 2/3. So at that point right there, at x equals 0, f prime of 0 doesn't exist. The derivative doesn't exist because of the cusp. And so the idea is you can actually draw many different tangent lines. So it's like that. Okay, so that's one of the examples. A corner, so you know the graph of absolute value of x looks like this. So at this corner, at x equals 0 only, this is the only one, there's many different tangent lines there, so f prime of 0 doesn't exist. I'm looking at the graph of y equal root x. That looks like this. So at this point right there, just at that one particular point, I can draw many different tangent lines, so f prime of 0 doesn't exist. And then this last graph, y equal x to the 1/3, this is got a vertical tangent right there at x equals 0, so f prime of 0 doesn't exist because you know a vertical line doesn't have a slope. All right. Let's look at these two. True or false? True or false? True or false? Okay. If a function is differentiable, then it's got to be continuous. If it's differentiable, then it's continuous. Yes. So if I can find the one tangent line at a point A, then that means it has to be continuous. I have to be able to draw it. If it's continuous, then it's differentiable. No. If it's continuous, it's not this. These are all kinds of examples right here. All four of these examples are continuous and not differentiable, so that's false. Okay, so let's just kind of look at this graph. F of x is absolute value of x minus 2. You know that that's just the absolute value graph shift over 2. So is this differentiable at x equal 2? No, because it's a corner. That's all you'd have to say. And how would you draw the graph of the derivative? Okay. So if I was to take the point like x equals 0 and draw a tangent line, it looks like, I don't know, -1, and it would still be the same there, right? And still be the same there. Okay. So let's see. At before 2, slope is -1, and then I get to this corner where the derivative doesn't exist, so I'm going to put a hole there. And then if I go and find the slope of the tangent line at, like, I don't know, 3 and 4, that looks like a positive number. I know, like +1. So I'll get from these points here. Will you look at that graph? There it is. It keeps coming up.